In this video, we are going to learn how to calculate annual loan payment using compound interest tables. I have a problem here. Let's read the problem, then we will see what the problem statement is, what information is given in the problem, and based on that, we will work on the solution. So let's read the problem. While in college, Ellen received $40,000 in student loans at 8% interest. She will graduate in June and is expected to begin repaying the loans in 10 equal annual payments. Compute her yearly payments for this repayment plan. So, very simple problem as you can already see. Uh, this is about an educational loan. Ellen received $40,000 loan and now she has to pay it back with 8% annual interest in 10 equal annual payments. So two things that are important in this problem. We are talking about annual payments, right? So this is an annual payment problem. So let me underline that. So this is important. We want to calculate annual payments. Many loans in real life, you basically pay on a monthly basis or a bi-weekly basis. So those problems, uh, they are a little more difficult than annual payments problem because this is very simple. Our 8% interest rate is also annual. So we have everything in years. Interest rate is given in years. Uh, Payments are on annual basis, so everything is measured in terms of years, so that makes it consistent, right? So let's take a look at our what are the inputs that are given to us. So first of all, P, which is present value, present value of loan in this case. In an investment problem, it could be present value of the total investment, right? But this is a loan problem, so P is the present value of the loan, that is $40,000. Ellen has presently $40,000 loan that she needs to pay back. Okay, next important thing that is given to us is I, interest rate. Interest rate is 8% annual interest rate. And last thing that is given to us is number of pay periods or number of payments that Ellen is going to make. So that is N. Once again, it can be N can be number of years, it can be number of months, number of weeks, depending in the context of the problem. In this case, it is N is equal to 10 years or 10 payments, right? So 10. Okay, so that information is given. And we want to calculate A, and later A is basically represents annual uh, payment, or sometimes it is also called as equivalent uniform annual payouts, right, or payments, uh, because the amount will be same every year, same amount every year she will have to pay back for 10 years to uh, pay back her loan completely. So that's what we want to find out. F, letter F, which indicates future value, uh, that is not given in the problem, and we don't have to worry about that because we don't want to calculate future value. It's the problem of calculating the annual payment, A value, right? So F later is not important here. So let's use this simple formula based on the compound interest tables. We want to calculate A, annual payment, that is equal to P is given to you, present value is given to you, present value times, we have to multiply that by factor A given P, means find A given P. So that factor, A given P factor, we multiply P value by A given P factor, that we will find out in the compound interest tables. uh, Comma I, so we have to provide input, two inputs to find that A given P factor from the table. We need to provide interest rate, which is 8%, and N is the number of payment periods, which is 10. So let's put the plug in the values. P is equal to $40,000 times multiply by A given P factor. I is 8% and N is 10. So now, where can I find the compound interest tables? So if I simply do a Google search, compound interest rate tables, okay, or compound interest tables. So I get the first link here. Uh, that is a PDF document. So I just open that. Okay, let me make it bigger. So in compound interest tables, you can find lots of factors based on what is given and what you want to find out. If P is given and you want to find out F, you should be looking for F given P. If F is given and you want to find out the present value P, then P given F factor, and so on and so forth. In this problem, we are looking for A given P. P is given to us and we want to find out equivalent A. So that is the factor we are looking for, right? So I'm going to scroll down. So first thing to note is this table, what interest rate is given. So this is 0.25% or 1/4%, but we need to look at 8% compound interest tables, 8%. So we scroll down until we get 8% compound interest table. So I'm at 3%. Here is the 8% compound interest table. Okay, so now we got the right table. And if you look at these column captions, you will see there are various factors that we can pick up from this table. F given P, P given F, A given F. If future value is given and we want to find out equivalent annual payments, that would be A given F factor. For us right now is uniform payment series factors are important, and particularly we are looking for annual payment given present value, A given P factor. So this is the column we should be looking at. Then on the first column here, N, the number of payment periods or number of periods, we know that we have 10 years. It can be anything, 10 years, 10 months, but in our case, everything is in years. So 10, row number 10. In row number 10, we are at 8, in the 8% compound interest table at 10 year, n is equal to 10 year. The P, A given P factor, sorry, A given P factor, this factor is what we are interested in, 0.1490. So that's what we have. So this whole thing now, we found out the factor, which is 0.1490. And if you multiply this, if you do simple multiplication, you should get the answer. 40,000 multiplied by 0.1490, that should give you this 5,960. So what that means is, that means Ellen has to make every year, she has to make a payment of $5,960, and she is going to make 10 such payments to completely pay off her educational loan. So very simple problem, as you can see, straightforward. Everything is given in years. All you have to do is first write down what is given to you, then write down what you want to find out, and then based on what is given and based on what you want to find out, you multiply what is given by an appropriate factor, A given P, P given A, whatever that is, and then look in the compound interest tables the value of the factor and do your calculation. So thank you, I will stop here.